Hello everyone. Welcome to the Engineering Geology and Hydrology course. In previous classes, we have already covered topics such as stratigraphic structure, fold structure, and fracture structure. Now, what's the relationship between these geological structures and our engineering construction? In this class, we'll study Chapter 3, the relationship between geological structures and highway engineering, divided into three aspects. First, the relationship between stratigraphic structure and highway engineering. Second, the relationship between fold structures and highway engineering. Third, the relationship between fault structures and highway engineering. Firstly, let's look at the relationship between stratigraphic structure and our roadbed engineering. We all know that stratigraphic structure includes horizontal strata, vertical strata, and inclined strata. So, how do different stratigraphic structures affect our roadbed and slope stability? Let's learn about it. Firstly, horizontal strata and vertical strata are beneficial to the stability of our slopes. Let's look at the two pictures below. This is the slope we excavated, where the left is a horizontal stratum and the right is a vertical stratum. In this case, our horizontal and vertical strata are more advantageous for this slope, meaning that such a slope is less likely to collapse. Regarding inclined strata, we have three scenarios when the tendency of our strata is opposite to the slope direction of our slope. This is extremely beneficial to the stability of our slope, which we also call an anticline slope. For example, in the picture below, the slope direction points to the left, while the tendency of the strata is to the right. The tendency of the strata is opposite to the slope direction of our slope. At this point, our slope is not prone to collapse. When the tendency of our inclined strata is the same as the slope direction of our slope, if the dip angle of the strata is greater than the slope angle of our slope, this is also beneficial to the stability of the slope. For example, in the picture below, the tendency of the strata is to the left, and the slope direction is also to the left, but the dip angle of the strata is greater than the slope angle of the slope. At this point, our slope is also not prone to collapse. If the tendency of the inclined strata is the same as the slope direction of our slope, and the dip angle of the strata is less than the slope angle of our slope, this is extremely detrimental to the stability of our slope, which we also call a conformable slope. Conformable slope is extremely detrimental to the stability of slope. In rocky slopes, conformable slopes that experience sliding instability account for about 80%. Below is a photo of a conformable slope sliding, where we can clearly see this slope. It isn't very steep, and the rocks are relatively fresh. However, due to the slope direction of the strata being the same as the slope direction of our slope, and the dip angle of the strata being gentler, less than our slope angle, this slope slides along stratal plane. The relationship between strata and bridge engineering. Horizontal strata and vertical strata have little impact on our bridge foundations. However, for monoclinic strata, when the strata dip downstream and there is a weak interlayer, the weak interlayer may become hollowed out due to the erosion of water, affecting the stability of the foundation, causing differential settlement of the foundation, leading to skewing or overturning of our pier. Second, fold structures have a significant relationship with our highway engineering. There is a strong relationship between strata and road engineering. For example, when our tunnel passes through a fold structure, should we place the tunnel in the core of the anticline, or in the core of the syncline, or in the flank? Which option is more reasonable? Let's analyze it. When our tunnel is placed in the core of the anticline, the core of our anticline develops a large number of tensile joints, so the top of our tunnel could possibly collapse. Moreover, because a large number of tensile joints develop in the core, groundwater tends to gather at the position of the core, which is unfavorable for the construction of our tunnel project. When our tunnel is placed in the core of the syncline, since the core of our syncline is squeezed, the rocks are more fragmented, so it is also unfavorable for us to construct our tunnel project. So generally, when our tunnel passes through a fold structure, it is better to choose to pass through the flank. The relationship between strata and road engineering. We all know that fault structures have a huge impact on highway engineering construction, so we should try to avoid fault structure zones in engineering construction. When setting the bridge position, if the bridge location cannot avoid the fault, we should place the bridge position on the same side of the fault. Our tunnel route should also try to avoid the fault. If it cannot be avoided, we should try to pass through the fault structure line, perpendicularly or at a large angle. Remember to avoid our line passing parallel with the fault structure line. When our tunnel crosses a reverse fault, we should clarify the position and thickness of the aquifer of the upper plate rock body of the fault to prevent flooding phenomena from occurring during tunnel development, posing great hazards to our project. In this class, we primarily studied three aspects of content. First, the relationship between stratigraphic structure and highway engineering. We should focus on understanding the impact of different stratigraphic structures on engineering construction, such as horizontal strata, inclined strata, vertical strata, which are beneficial to the stability of slopes, and which stratigraphic structures are detrimental to the stability of slopes. Second, the relationship between fold structures and highway engineering, such as when our tunnel passes through fold structures. Should our tunnel choose to pass through the core of the anticline or syncline, or should it be better to pass through the flank? Third, the relationship between fault structures and highway engineering. Fault structures are extremely detrimental to our engineering construction, so in our engineering construction, we should try to avoid faults as much as possible. If we cannot avoid them, our lines should pass vertically or at a large angle through our faults. We've basically finished learning about geological structures, but how are these geological structures represented on geological maps? In our next class, we will teach you how to read geological maps. See you in the next class.